Hey physicists, just a quick little review of position versus time and speed or velocity versus time graphs. I've gone along here and I've collected some data. I was checking my position. You can see every 2 seconds at 2, 4, 6, 8, all the way up to 12 seconds, and I recorded my position. At 0, 1, 4, 9, 16, 25, and 36 meters. So I've drawn my picture here, and you just get an idea that I'm at 0, 1, 4. But one thing that's kind of interesting is I go along, I'm speeding up because I'm covering more and more distance as I go along. First, we'll plot that as a position versus time graph, and then we'll take a look at how the speed changes with time. Okay, in physics, almost always our independent or x-axis will be our time axis. So let me go ahead and mark that as being time. We're going to measure that in seconds. Sorry about that. Okay. And our vertical axis, in this case, will be our position. Will be measured in meters. Okay. Title of our graph: position versus time. Okay. Let's go ahead and figure out a scale here. We know we're going to a maximum of 12 seconds. I've got 15 divisions here. So it looks like one division per mark will work out well. 4, 5, 6. You can see I've written that out to 15. Let's take a look at the vertical axis. We have to go all the way up to 36 meters. I've got 15 divisions here. So if I do 1 meter per division, that will get me to 15 yards. 2 meters per division gets me to 30. The next one I'll want to choose is 5. That would get me to 75 meters up here. And that'll take care of all 36 meters that we have. So I'll go ahead and mark that. So I've gone ahead and mark this 5, 10, 15, and 20 meters up to 75. So what I'll do now is I'll mark my positions, both the x and y coordinates for that. My initial position, 0 and 0. At 2 seconds, I'm at 1 meter. About here. At 4 seconds, I'm at 4 meters. Hold on it. At 6 seconds, I'm at 9, and so on. Okay. Now I can draw a smooth line through this, indicating my motion. Now, if I were to take a look at my average speed is the distance I've traveled, 36 meters, divided by the time it took me, 12 seconds. I get an average speed of 3 meters per second. But I can see that 3 meters per second really doesn't reflect what my motion is like. I see that I'm speeding up, so let me take a look at what my motion would be throughout this time. Now, velocity is our change in distance divided by our change in time. Remember, we've used this little triangle or delta symbol to mean change. We could do that over the entire interval from 0 to 12 seconds and look at our change in distance from 0 to 36 meters. But we can look at it also at any small interval as well. And we'll do that and see if that gives us a pretty good idea of how we're moving as we go along. So my change in time will be the change in time since the last time it collected data. At the first point, there's no change there, so we won't be able to figure out anything there. But the second position, it's been 2 seconds since we've collected data. Or another way of saying it is 2 seconds minus 0 seconds. At 4 seconds, again, it's been 2 seconds since we've collected data, so 4 seconds minus 2 seconds, 2 seconds. And again, you can see the pattern. At 6 seconds, it's been 2 seconds since we collected data. At 4 seconds, 6 minus 4, again is 2, and I'll fill out the rest of that chart. Or really, I should call this a table. 2 seconds between each of the motions. Now, the next thing is our change of position. How far have we moved since the last time we collected data? Again, we're at the 0 position. We're just starting. At our first interval, we're at 1 meter. We've moved, subtract the 0 meters from our initial position. We've moved 1 meter since we started. Our second position, we're at 4 meters. We started at 1 meters. 4 minus 1 gives us 3 meters. And you'll start seeing this. 9 meters for at time 6 minus the 4 meters that we started. During that time interval, we moved 5 meters. End up seeing now we moved 7 meters. We've moved 9 meters. And this last one, from 25 to 36. During those 2 seconds, we moved another 11 meters. Now let's go take a look at what our velocity is over any of these time intervals. Remember, this formula here can be used for the entire interval from 0 to 12 seconds to get our average speed, or we can use it over any one of these one intervals. So let's take a look at this first interval. How far did we move? We moved 1 meter. How long did it take us? It took us 2 seconds. So our speed here is, the average speed is 1/2 meter per second. Let me go ahead and write in the meters per second so we know that that's what our unit is. Our change of position should also be in meters, and our change of time in seconds. If I write it out here at the beginning of the table, I don't have to write it for each of the values. Next thing is we changed. Our change of position was 3 meters, and it took us 2 seconds. 3 divided by 2 is 1.5 meters per second. Let's go on to the next one. In this interval of time, since 4 seconds until from 4 seconds until 6 seconds, we traveled 5 meters, the distance from 4 to 9 meters. So we traveled 5 meters. 5 divided by 2 is 2.5 meters per second. Again, 7 meters divided by the 2 seconds of our interval, 3.5 meters per second. Again, this one, we're traveling at 9. We've gone 9 meters in those 2 seconds, so we're at 4.5 meters per second. And this last one, we've traveled 11 meters in 2 seconds. We can see our average speed is 5.5 meters per second from the time of 10 seconds to 12 seconds. This gives us a much better idea of what our motion is like. We said our average was 3 meters per second over that time, which is true, but we started off very slowly. Half the time we were slower than that, half the time we were faster than that. Let's go ahead and plot it on this on this chart here. So in my chart of speed versus time, I've already labeled the x-axis, my independent variable, at 0, 1, 2, 3, 4, up to 12 seconds. That's time in seconds. Our vertical axis will be the dependent variable. In this case, it's going to be speed. And we're measuring that in meters per second. Let's look at the scale. We know that we have 15 divisions here, and we only have to get to a maximum of 5.5 meters per second. And our, rule of 1, 2, 5, 10 units can also be used the other way. So we can also go a half unit, or 0.2 units, or 0.1 units would also be a reasonable way of doing that. Go to 15, probably still a little bit too coarse. If I used a half meter per second for each of these, up to 15, I go up to 7.5. That looks like a pretty good unit. I'll go ahead and label this axis that way. So I've labeled the vertical or y-axis in 0.5 meter per second units. Now let's go ahead and plot the data. So at 2 seconds, I'm at 0.5. At 4 seconds, I'm at 1.5 meters per second. At 6, you can start seeing a pattern here. 2.5 at 8 seconds, 3.5 at 10 seconds, 4.5 at 12 seconds. We're at 5.5 meters. On a smooth line through that. Should be nice and straight. Sorry, I didn't have my straight edge with that. Let's just take a look at one other situation. And in this case, again, we're measuring our time every 2 seconds. We're checking the position. We can see the person is moving forward, gets out to 10 seconds, waits there for just a few moments, and then starts heading back. So their motion is kind of this direction, gets here for a little bit, and then starts coming back. What would that look like in our 2 positions? Let me go ahead and fill out our position versus time graph, and then we'll talk about the speed, or now we'll start talking about velocity graph. So in our position versus time graph, I'm at 0, then you can see 4, 8, 10, stay at 10, then go back to 6, and then finally end up at 2 meters. Let's go through that same exercise to figure out what our average speed is. Okay, overall, our average speed is our change of position, which from beginning to end is only 2 meters. And it took us 12 seconds to do that. So we're only averaging 1.7 meters per second forward, but that doesn't really tell the whole story. Let's go ahead and check our change of time, just like last time. The first one, because we don't have anything to compare against, we won't have anything there. But the second one, it's been 2 seconds since our last measurement, and I'll fill out the rest of this. We're making measurements every 2 seconds. Okay. But how about our position? You can see our position changed. We're now at 4. We were at 0, so we moved forward 4 meters. Then we went to 8 meters from 4 meters, so 8 minus 4 is another 4 meters forward. Here, okay, we're at 10 meters. We were at 8 meters, so we went 2 meters forward. Next measurement, we're still at 10, so we didn't change our position at all, 0. How about this one? We went from 10 to 6, so we had to have gone backward. So another way of thinking of this is 6 minus 10 is actually a minus 4 meters. And again, then we went from 6 to 2. 2 minus 6, again, minus 4 meters. And again, I can use my speed or velocity equation for any interval along here to find out what my speed or velocity was at that point. So I can use my change of position, 4 meters divided by 2 seconds, so 2 meters per second. You can see I've already noted the units there. Again, 1 meter per second. We didn't change it all for 2 seconds, so we're standing still, 0 meters per second. Then we get this interesting one. We're going to actually indicate backward by a minus, oops, let me go write that again, a minus 2 meters per second and a minus 2 meters per second. So we're starting to introduce the idea of not just speed, but velocity, which is velocity is speed with direction. The minus sign indicates that we're going backward. So now let's look at our, I'm now going to call this velocity rather than speed because we're worried about direction. My velocity versus time graph. We're at 2 meters per second, then we slow on down to 1 meter per second. We're actually stopped here. Then we're going backward at minus 2 meters per second, and we stay going backward at 2 meters per second. So this ends up representing our motion and does a better job of saying, rather than saying, hey, we average going forward at 0.17 meters per second. I was going forward pretty quickly. I slowed down. I stopped for a few moments and then started going backward.